So now just go ahead and review this program, right? And you will notice what is the expectation. The count number to print minus 4 times count minus 4 times counts plus 21. And that will give you 17, 13, 9, 5, and 1, right? So that's the easiest thing. You will start it with minus 4 times count. So count is gonna keep increasing and you just keep adding 17 to it, right? And that's the way you will achieve 17, 13, 9, 5, 1. So this is the print statement and you will achieve it just by using this particular loop concept. Okay. Now let's just go to the next thing. Nested loops. So that means, again, this is just the exercise. I believe you guys should be able to do it on your own, right? So let's just move on. Let's just run this particular program and you will see you can print this series as you see dot 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 1 dot 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 2 dot dot 3 dot 4 and 5. Let's just try this one out. Just go ahead and run this program and you can see the output, how it is generated. There you go. Okay. All right, let's just continue with this. This is just the exercise and you guys can see what is the output, right? If you want to generate this type of output, dot 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 1 dot dot 22 dot dot 333 dot 4444 5555. So let's just run this program as well. Run this program. Again, I'm still using the same class hello world. You can use the same class or keep creating different programs, and there you go. This is the output. So I'm using a nested loop. Nested loop. I have a loop inside a loop. I have another loop inside a loop, and that's what's producing this type of output. So you have to first analyze the problem and make sure the output aligns that way. Right, so that's the way it's gonna look, the output. Now let's just continue. These are just some of the exercise that you guys can try it at home. You can just see how to modify the output and how to generate it, right? And this is again the answers as well. So in case if you guys want to try something on your own, this is just one way. Let's just run this as well. Copy this, go to the Eclipse and paste this loop, and you will see how your output, again, you are using a nested for loops with all these things. So just go ahead and run it and you will see how your output is generated, how it's changing. That's important thing to see, right? And that's what will show you how it will keep changing from this to this to this to this and to this, right? So let's just move to the next thing. How do you draw? Sometimes you will get a problem statement like draw this particular ASCII chart, draw some kind of a figure, draw some kind of a complex algorithm, right? You can perform all these things using a for loop statement. It's just about you have to put proper counters in, use a same, like in this diagram, you are using this as a start sign and this is an end, and you are using this as the beginning and then this less than sign greater than sign, and dot. So you are using symbol 1, symbol 2, symbol 3, symbol 4, symbol 5, symbol 6. So you are just using a 6 symbols over here. So let's see how to write this logic. So you will design the program and think about the steps and the methods. Write an English description of the steps, use the description to decide the methods, and create a table with a pattern of characters. So it will look something like this. Pseudocode. A pseudocode is nothing but an English description of an algorithm, right? That is what the pseudocode. So before you start writing any program, your job is to write the pseudocode for that program. Now let me show you the examples for the pseudocode. This is just one of the example. It is written in English. You have print 12 stars. For each of 5 lines, print a star, print a 10 spaces, print a star, continue for next 5 lines, and then at the end, print another 12 stars. So print the 12 stars in the start, print the 12 stars in the end, and then print a star and print a 10 spaces, and then print a star. And just go back to the line 2, line 3, line 4, line 5. So for each of the 5 lines, configure this algorithm. So this is what we consider as the loop or as the output. Okay. Now let's just continue with this. This is also a pseudocode. So how you will solve the pseudocode? For this particular problem, if somebody asks you to resolve a pseudocode, what you will do to resolve the pseudocode for this? Okay. The first is, this is gonna be the line print a hash 16 equal and a hash, and then this is your entire pseudocode to generate. So just review it and it will generate this diagram. Remember, you cannot just copy this and paste it in your Java compiler to print and it will run as Java. It's not. It is a first prerequisites before you start designing your Java programs. This is your first step that you will perform, right? And then you will convert this entire pseudocode into the algorithms. That's the way you will define all these things. Okay, let's just continue. This is a method for pseudocode. You have a line, top half, bottom half, and a line. So when you are at this point, it will call this line method. When you are at top half, it will call this method. When you are at bottom half, it will call this method. So now you are creating methods from the pseudocode and writing it as a, remember, every time your Java program start execution, it will look for a main method. As soon as it finds the main method, it will start executing statement 1. So it will jump here and execute this. And when you are finished with this loop, it will go to this one. Then it will execute top half and perform this execution. Then it will come out of this loop and generate the bottom half and perform this calculation. And then it will generate a line and it will complete this one. This is just the table, right? Line 1 spaces 6, line 2 space 4, line 3 space this. And that's the way you will start designing. So now we are converting the pseudocode into how we can solve this problem. That's what we are going to. Right, there you go. So at line number 1, you have a 6 spaces, so you will achieve it with this way: 1 times minus 2 plus 8, and dots. How many dots are there? 4 times line minus 1. So 4 minus 4, so 0 dots, and that's the way you can achieve this one. Line number 2, you will have 4 dots, so the 1, 2, 3, and 4. Line number 3, you will have 6 dots or 8 dots, so 8 dots and then this. And that's the way you can perform this algorithm and generate this diagram for you. How do you write the code for this? You will just convert your pseudocode that you have written and simply convert it into this particular Java program to solve this problem. This is just a partial solution, right? And this is just about your top half method. And you can just go through the details about the logic about the top half. Then this is about the bottom half, you will get the solution. And then about the line, if you combine all the three things, then it will solve this particular problem that you see it over here. Okay, let's continue. Class constants and a scope. What is a class constant? What is a constants first of all? The number of days, 7. Your age, it's not constant, it can keep changing. Number of days or number of months in a year, that is constant. The value of pi, that is constant. The maximum speed of your vehicle, that is not a constant, it can vary. Your age, it's not a constant, it can vary, right? Your t-shirt size, medium, that's constant if you purchase one t-shirt, right? So my point is, how do you define something as a constant in Java? So let's just go over that now. First, let's understand the scope of variables, and then let's first go over the final keyword. Let me show, there you go, class constant. So a fixed value visible to the whole program, and it cannot be reassigned or it cannot be updated. Whenever you type public static final, whenever you put a final keyword, the data type, the variable name, and the value, then you cannot change this value throughout your execution of Java program. As soon as you put final, it will not allow you to update this value inside your Java program. This is what we refer it as a class constant. So let's just try this one out. I'm just going to try a sample thing right now so you can see the difference. First of all, let me declare a variable that is not a constant. Just print this. This is not a constant, remember. Now we will declare something as a constant. So static final double pi equal to 3.14. Just print the value of I, for example, pi. Okay, not constant. Now run this program. Just do only final, not static. Run this one, click OK. See the output. Now let's just try to update the value of I to 1. Print this and run this program. There you go, it worked. Let's try to update the value of pi now. And then try to print it. Look at the message here. The final local variable pi cannot be reassigned because the value is constant. So you are not able to assign this thing to some other variable, right? So the quick fix is remove the final modifier or do not assign it. If you just don't do it, the error will go away and it will print the same thing throughout this 3.14. But you are allowed to change the value of I because that is not a constant, it is a variable. So it will keep changing the value of I for you. All right. Let's just continue with the next thing now. So what you should do is, if you want to make changes, number of days. So final number of days integer equal to 7. So nobody can change number of days value in your program because you have declared this as integer number of days is equal to 7. All right. That's all we have for this program lecture. Let's just continue in the next lecture about this variable scope and everything. All right. Thank you all for watching the video.